He kōna ipurangi tēnei nā te reo irirangi o Aotearoa.
Kia ora, and welcome to Elemental, a podcast from RNZ. I'm Professor Allan Blackman, Professor of Chemistry at the Auckland University of Technology and avid periodic table fan.
And I'm Alison Ballance, a chemically curious science producer from RNZ. We're up to episode 8 in our alphabetical adventure through the periodic table, and we have finally arrived at the Bs. What's the story with barium, Alan?
Barium. How do we pronounce barium to begin with? Because if you look around the place, you will see it called barium or barium.
I've never heard it called barium. Is this like an Australia-New Zealand pronunciation thing?
No, I don't think so. I think it's more an English pronunciation, in fact.
What do you call it?
I call it barium, but one of the guys that I worked under in my PhD, he always called it barium. So,
okay. Tomato, barium, barium, off you go.
Okay, barium, the elemental symbol Ba, and it is number 56 on the periodic table, which puts it a little bit sort of below middle on the left-hand side. And barium first came to exposure, pardon the pun, as part of things called Bologna stones in Italy in sort of the 1700s. And these were weird things that were found to phosphoresce. So you expose them to light or you expose them to heat, and then you put them in the dark and they glow in the dark. Their name comes from the Greek baris, meaning heavy, and it ends in IUM because it's a metal.
So it's got a name that means heavy and it's a metal. Is it a heavy metal? Kind of seems obvious.
Yeah, you probably wouldn't actually call it a heavy metal. They're more over towards the other side of the periodic table, your classic heavy metals. Barium's on the left-hand side of the periodic table. It's in group 2, and our previous episode on astatine, we talked about groups as being the columns on the periodic table. So this is in the second column of the periodic table. And its buddies in that particular group are elements such as beryllium, which we're going to do in our next episode, magnesium, calcium, strontium, and radium. And again, the fact that they're all in group 2 means that they behave chemically similarly. So we've talked about the columns on the periodic table. What about the rows on the periodic table? The rows, the ones going across, we call periods.
Hence the periodic table.
Yes. Also the fact that period in the sense of repeating. And the way that that works is that as we go across a period, we eventually come to an end and we go back and we start again. So as we go along a row on the periodic table, what we're physically doing is filling electrons. We're giving them more and more and more and more electrons until you get right to the right-hand side of the periodic table. That particular shell of electrons then becomes full, and we start another one, and we go back to group 1, and we start going across another period on the periodic table. So, as you say, hence the name periodic table.
And the fact that this is in group 2, and you're saying it's to do with the number of electrons, 2 electrons then?
Indeed, yes, 2 electrons. As we talked about in the last episode of astatine, we said that all of the elements in group 17 like to have 1 more electron and form a 1 negatively charged ion. All of the ones in group 2 really want to lose 2 electrons and form 2 plus ions. So calcium and magnesium and barium and all of these group 2 elements all form 2 plus ions. And therein lies their sort of similarity of chemical reactions. So they all behave fairly chemically similarly. So what you find is that barium doesn't exist as the free metal in nature because it really, really, really likes to get together with oxygen, also with sulfur, and it forms compounds. And you find these compounds as minerals such as barite, which is barium sulfate, and witherite, which is barium carbonate. And so if you want to get pure metallic barium, you generally start with those particular compounds. And barium historically is very, very important in the development of nuclear fission, because when people started playing around with uranium, shooting neutrons at uranium, what they found was barium was formed, and they couldn't figure out how barium could possibly be formed from uranium. But then they figured out that what must be happening is that the uranium nucleus must be splitting essentially in half. And that was a very, very important observation.
Indeed it was. So what does one actually do with barium?
Well, there's lots of things that barium can do. Because it is a so-called heavy metal, it can be used in oil drilling fluids as weighting agents, white pigments in paints. Back when TVs had vacuum tubes, The tubes used to contain barium because they would be under vacuum. You didn't want any oxygen in there. And so because barium, as we said, really, really likes oxygen, you'd have metallic barium in there, and it was called a getter.
Because it got the oxygen.
Indeed, because it got the oxygen, absolutely.
Huh.
And the use of barium that we would be most familiar with would be barium meal, which is an X-ray diagnostic test, which is what you have when you want to get an X-ray of your soft bits, intestines and stomach, etc., etc.
I actually did some homework for this episode because I thought, barium sounds familiar. So if your doctor wants to X-ray, say, your esophagus or your stomach, then you drink this thick white gloop known either as a barium swallow or a barium meal. That goes in from the top end, obviously. And if they want X-rays of your lower intestine, then you get a barium enema. And that's basically poured in from the other end.
Indeed.
And either way, apparently it's quite harmless, but it's also rather unpleasant and might make you a little constipated.
Well, here's the weird thing, because if you just take a simple salt of barium, something like barium chloride or something like that, what you'll find is it's very, very poisonous. And barium sulfate, which is the stuff that they use for the barium meals, technically, because it contains barium, it's very, very poisonous as well. And here we've got the doctors feeding you this stuff with no harmful effects. And the way that works is that something like barium chloride is water soluble. So that means if you ingest it, it can get all around the body very, very easily and it'll kill you. Whereas barium sulfate is really insoluble. And so all that it does, it forms a coating over all of your soft bits inside, and then it gets excreted out the other end, and it doesn't kill you. So the fact that it is poisonous is shown by the fact that you use barium carbonate as a rat poison. And barium carbonate, you put that in an acidic stomach, that then solubilizes it, and you end up dead. A little known fact, the terracotta warriors, those famous statues from Xi'an in China, are coloured with pigments called Han purple and Han blue, and they are pigments which contain barium in addition to copper, and it's the copper that actually gives these the colour. And so from imperial China to modern America, a mineral called bonitoite, which is barium titanium silicate, is in fact the official state gem of California. And where we would see barium in action at least once a year is in fireworks, because if you put barium salts in a flame, they give you a beautiful green colour. And so all those greens that you see in fireworks are very, very probably barium salts, which, let me remind you, are in fact toxic and are spreading all over the land in your big fireworks displays.
Oh, I'll remember that next time I go to the Matariki firework display here in Wellington. Hey, apart from the fireworks, would I come across it in my daily life?
Well, in fact, you are around about 22 milligrams barium yourself.
So I'm part barium.
Yes, indeed, you are. Barium is in food, even though it's poisonous. It is in food such as carrots and onions and lettuce and beans and cereal grains, and apparently particularly Brazil nuts, and people can get a little bit worried about the levels in Brazil nuts. And very, very interestingly, barium levels in your teeth can help scientists figure out exactly when a baby has transitioned from breastfeeding to eating solid foods. So there's an example of a Neanderthal baby which scientists analysed and figured out that it had been breastfed until it was 7 months old. And the way that they did this was to look at the ratio of barium to calcium in the teeth. And you might ask, why would you have barium in your teeth? Simply because, again, barium is in group 2 of the periodic table, so is calcium. They look very, very similar to the body, and so therefore you can get barium in parts of the body where calcium likes to be.
That's brilliant. So actually barium's a really useful element. Anyway, that's it for this episode of Elemental. You can find us online at rnz.co.nz/chemistry.
And we are also a podcast at Apple Podcasts and Spotify, as well as other places. I'm Professor Allan Blackman from the Auckland University of Technology.
And I'm Alison Balance. Catch you next time. Mā te wā.